I will be showing you how exactly a DAC can be interfaced to the 8051 microcontroller. So I told you in the theory class we have got a DAC IC by number 0808 which converts the digital information into the analog information. So in the interface what we have in the laboratory, we have connected DAC IC to port P2. So please keep this thing in mind. So DAC is connected to port P2. The digital input, whatever we are giving, we will be giving through port P2. Now let us see how exactly this will going to convert the given digital into the analog information. So this is the formula, or this is how we can find out what is the output we are going to get. So in DAC IC we are going to get output in form of current. So therefore here it is mentioned as I out. So the current coming out of this DAC IC will be proportional to the digital input whatever we are giving. So the current coming out of this is converted into the voltage by using a current to voltage converter, or an op-amp is used here to convert the current into voltage. Now let us see how exactly to calculate the voltage or output voltage. So this is the formula, or I told you at the output we are going to get the current I0. So the current I0 is given by this formula. So I0 is given by V out divided by RF. That's what I have written here. Similarly, I reference is given by V reference divided by R reference. So if you substitute these two things into this formula, we are going to get this. Here RF and R reference, both of them is of 5K. So therefore these two gets cancelled. Now this is the formula by which we can calculate the output analog voltage depending upon the digital value what we are giving at the input. So now coming to this formula, if my V reference, you can see in the interface it is equal to 10 volts. So therefore I have substituted V reference as 10 volts. So first what I do is I am going to give the analog information or 8-bit information as 00. Since it is 00, from D0 to D7 all of them will be 00. Since all of them are 00, if you take the total value, or if you calculate the value of this, it will be equal to 0. 10 into 0 will be equal to 0 volts. So I am going to get 0 volts. Next I want to give FF. So if I give FF, then what exactly I am going to get is 10 volts. So from this examples, it is clear that in this interfacing, if you give 0, then our digital value, if you give 0, then I am going to get the analog value as 0 volts. Similarly, if you give FF, you can see this is D0, D1, D2, D3, D4, D5, D6, D7. All of them I have given 1, 1, 1. So therefore, the input will be FF, or the digital data what I am giving from here is FF. Since it is FF and V reference is equal to 10 volts, the output I am going to get it as 10 volts. Now let us see how or what is that we have to do. So now we have to generate, so we will be generating a square wave. So now I have to generate a square wave of frequency 1 kilohertz and amplitude 10 volts. So to get 10 volts, I have to give FF, which is very clear from this expression. When you generate a square wave, you will have 0 and then 10 volts. To get output as 0 volts, we have to give the digital input as 0, and to get the output as 10 volts, we have to give the digital input as FF. The calculations are shown here. Once we give these values, we are going to generate a square wave. So now I want to generate a square wave of frequency 1 kilohertz, and the frequency, if you convert into time, it will become 1 millisecond. Now I am trying to generate a square wave with a duty cycle of 50%. Once the duty cycle is 50%, my on period will be equal to off period. So therefore, since these two are equal, I have to take T by 2 equals T on and T off. T I got it as 1 millisecond. So 1 millisecond divided by 2, I am going to get 0.5 millisecond. So now what I am going to understand is to generate a square wave of 0 volts for 0.5 milliseconds. first I should send digital value from here as 0, and then I should call a delay for 0.5 millisecond. After 0.5 milliseconds, I have to give, or I should send a digital value of FF. The moment I give FF, I am going to get 10 volts. Once I get 10 volts here, I want to give a delay of 0.5 millisecond, so that one square wave gets generated, and this I want to repeat a number of times. So therefore this program I want to repeat. Now let us see how to write the program for the same. So I have shown you the calculation. So now here you want a delay of 0.5 millisecond. So to get 0.5 millisecond of delay, what I am doing is I am using timer 1 in mode 1. So you know that mode 1 is a 16-bit timer, and the crystal frequency standard value what we use for 8051 is 11.0592 megahertz. Unless and until it is not specified, always we are going to use the crystal frequency as 11.0592 megahertz. Once I know the crystal frequency, I can calculate the machine cycle. So machine cycle is given by 12 divided by 11.0592 megahertz. So I am going to get one machine cycle equals 1.085 microseconds. So since I know what is the time required for one machine cycle, I want to calculate how many machine cycles are required to get a delay of 0.5 milliseconds. So therefore what I am doing is I am dividing this 0.5 millisecond by 1.085 microseconds. So this is the time for one machine cycle, and this is the delay I require. So if I divide these two, I am going to get a number 460.8, which I have approximated to 461. Now this value 461 has to get a delay of 0.5 millisecond, I have to subtract this 461 from 65536 because it is a 16-bit timer. So 65536 minus 461, I am going to get 65075. But this is a decimal number. This decimal number I cannot directly load. So what we do is this decimal number I will convert it into hexadecimal. If you convert this into hexadecimal, you will going to get FE33. So since I want to have a delay of 0.5 milliseconds, the value that should be stored to TH and TL is FE and 33. So therefore I will be storing FE and 33 in TH and TL register, so that I can get a delay of 0.5 millisecond. So now this is about the calculation and how we have to interface to the 808 to the 8051. Those things we have seen. Now let us write a program so that we can generate a square wave. So what is that I have done is, first I am using timer 1 in mode 1. So therefore I have to put a value to the T mod. So I am moving 10H to the T mod, and then the digital value whatever I want to send first. So first in the square wave I want to send 0. So I am moving 00 to the accumulator. From accumulator it is moved to the port P2, because the digital value whatever I am giving here will be sent to 0808 through port P2. So therefore I have to send this value 0 to port P2. Port P2 will be acting as an output port. Now I have sent 00. Then I am going to call a delay. So once I say call delay, it is a subroutine. My microcontroller will stop executing the main program. So the next address is this. This will be stored in program counter. The address corresponding to this is stored in stack pointer, and the address of the delay will come to the program counter. So in program counter, what is that we have written is the delay program is there, or subroutine corresponding to delay is there. You know that to get a delay of 0.5 milliseconds, you have to store FE and 33 to TH and TL. So TH1 I am storing FE, and TL1 I am storing 33, and then I have to start the timer 1. So I am going to start the timer 1. So after starting the timer 1, I should wait for TF1 to set. So once the TF1 is set, I am going to get a delay of 0.5 milliseconds. So therefore what I do is I'll just wait till this is not set. I am telling jump no bit till TF1. If TF1 is having 0 only, then I will not get complete delay of 0.5 millisecond. Once the 0.5 milliseconds of delay gets over, automatically by the microcontroller, this TF1 bit will be set. So therefore, I will be waiting till this TF flag is set. Once it is set, now I have got a delay of 0.5 millisecond. So therefore, I will stop my timer and also I will clear this TF flag, and since I am in a subroutine, I have to go back to the main program. I have given return. Once I say return, the next address or the next instruction after my subroutine is this. So my program and microcontroller will come to this point. Here I am moving FF. So first I have moved 0, 0. Now I am moving FF. So this FF is given to port P2. You are seeing that by giving FF, we are going to get 10 volts, or we can get 10 volts of square wave. So now after moving 10 volts, I should generate a delay of 0.5 millisecond. So I have to call this program again. So therefore, I will call this delay program. After generating delay of 0.5 millisecond, I have generated the T low or T off, and then I have generated T on. This has to repeat continuously. So therefore, what I have done is, from here I have gone back to the repeat. Once I go to the repeat, the program will be repeated n number of times. Since it is repeated n number of times, continuously square wave will be generated. The generated square wave will be available at this point. So if you connect here a CRO, you can see the square wave, and the frequency of this square wave is 1 millisecond, or it is equal, time is 1 millisecond. So therefore, frequency will be equal to 1 kilohertz, and this is 0.5, and this is 0.5, and this is my 10 volts. This is what I have to observe in my kit. So now I know how exactly 080 is interfaced to my microcontroller kit, and what is the waveform I have to generate. Depending upon the type of waveform I have to generate, I have done the calculation so that I can get the required amount of delay. Then I have written a program, and once this program is dumped into my kit, automatically a square wave is generated. The generated square wave you can observe in the CRO. Now let us go to the kit and try to dump this program, and then we will see whether the generated square wave of this value. So let us go to the kit. So as it was told in the last class, whenever we want to dump the program, first we have to create the hex file. So here what I have done is, I have created a project. So the project is square wave, the name I have given, and then I have written the program. So this is my square wave program, and this particular program is added into the project. So this is my target 1. So as I have explained the procedure in the last class, now I have to set this one for target 1. So you can see we have set a frequency of 11.0592 because we are using the standard value of the crystal frequency. Then we have to give a command for generating the hex file. So once you click on this, the hex file will be created. So now what you can do is, you can just build all. So the moment you say build all, it is showing there is no errors and there is no warnings. Now I have to connect, or I have to dump this program into the kit. So for dumping it into the kit, I have to check which one or which port I have to use. So coming to here, so in the last class we have shown where exactly to see. So here you can see that port 24 is used for dumping the program. So therefore I have to use port 24. So now what I am going to do is, I will go to my SISP. So this is my SISP. So I will just click on to this. So already it is open. So I will select COM port 24. Then hex file square wave is already created here. So I will just say program. So once I say program, so chip verification is successful. Now I have to connect my CRO to the So now I have to connect my CRO. So before connecting CRO, I have to make my stepper interface or DAC program or switch into the switch on condition. Then I'll be connecting my CRO. So you can see this is my output and this will be my output. So I have connected my CRO. Connected the CRO. So now from the CRO or on the CRO screen I can observe the square wave. So if I just log this, you can see the readings. You can see it is giving. So you go here and press measure. So once you say measure and log this, it is going to give what is the frequency of the square wave. You can see it is giving a frequency of 967 Hertz. We have designed for 1 kilohertz and the amplitude I wanted is 10 volts. It is giving 9.68 volts. So now I am able to generate the square wave with frequency of 1 kilohertz and amplitude of 9.68. Actually I was supposed to do it for 10 volts, so I am getting 9.68 and frequency 967 kilohertz. Thus the frequency square wave can be generated using a DAC. So this is the DAC interface, and here you will have switches. That switch has to be switched on. If it is switched off, then you don't get the output. You can see here it is switched off. Now you are not getting any waveform. So now to get the output or to make this interface to work, first you have to switch on. So switch it on and then you are going to get the square wave. So once you get the square wave, you can see the measurement of the values whatever we are getting. So thus we have generated the square wave using DAC interface. So this is my DAC interface, and here I have connected the DAC IC 0808. So similarly we can do the generation of triangular waveform also. So that video will show next.